Okay, good day once again. You are welcome to the NUESA National 5 Days Workshop, the National Engineering Workshop. Well, we started the class yesterday, and today we are moving on to another module. I'm Stephen Aro by name once again, and I welcome you to the introduction to Aspen Hysys software, the basis. So, moving on, where we stopped the other day was the module 2, part of the module 2, where I was telling you about how to modify and specify your string and all that. So let me just do a recap on it. Let me just run you through it and see what how you should do that. Then we'll try and solve about 2 questions today, and that will be what we'll be doing today. So uh let me open one of the questions for you to see. Come, let me see. Yes, this is what we did yesterday. We did introduction where we talked about introduction to Aspen Hysys, uniqueness of Hysys, difference between Hysys and plus why Aspen Hysys. And I asked the question yesterday, don't forget, I asked you that what is the difference between simulation and modeling. So I hope you've all figured that out. And then the module 2 we talked about the Aspen Hysys basis. We spoke about starting Aspen Hysys, selecting components, define and select fluid packages, then how to enter and enter simulation environments, add and specify material streams. So basically today I'll be starting from add and specify material streams, and then we'll be looking at this module 3D, probably the first one, the pump, compressor and expander and all that. We'll try and see what we can do about that. So moving on, let me go to where I have this add and specify material streams. Let me open my Aspen Hysys for you so you can see what I'm talking about. So this is my Aspen page, as you can see, where you have the component list, the fluid package list. Now the first thing is what? To add your component list. As I said yesterday, you have the click add button. Now when you click on it, it displays a page whereby you can select your components. And I told you, if you haven't forgotten, that your components, you have both the pure components, the theoretical ones, and then the theoretical solids. Where the theoretical ones means you can create your own components. So okay, let's deal with these pure components today. Let's assume you are going for methane. Methane. You do what? Once you click on methane, highlight it, and then you do what? You add it to your system. So when you click on the add, you can then see it on the left side of your column. And then when you drag your column down, you see your status says what? Okay. Okay. Until it changes to green, it means it is not okay. You haven't added any component. So once you've done that, you will see that the component list here, the color changes also. But look at the fluid package. The fluid package is still on red. And then the next thing I told you about was taking note of this your message bar. You can see it says what? Required info. Fluid package, select property package. So let's select our property package. Whereby you click on the property fluid packages over here. And then you add, isn't it? Then to add it, you have to click on the add button where you have several fluid packages, and you have to determine that which one works for which one. That is what you have to do. And then I hope you haven't forgotten the table I recommended just during the last class. The table that guides you in selecting your components. If you have gases, which one do you go for? If you have electrolytes, which one do you go for? Take note of that. So let's go with Pen Robinson for this one. So once you click on it, you see that the status will go, you change to green also, and then you have OK, and then you can see that the color has changed here also. So after that, then you can enter your simulation environment. So your simulation environment, clicking on the simulation environment, and then you have the simulation environment. And hope you haven't forgotten the name of this place, your model palette, whereby you can select everything you need. You have the energy stream and the material stream. The blue one is the material stream and the red one is the energy stream. So what do? You know we are doing with material array, so you bring in your what? Material stream. And don't forget we are trying to do what? Specify a stream. Now it has a name of what? One. The color is probably a light blue, isn't it? So how do you specify this stream? Now whenever you have this color for a stream, it means it is not fully specified. So you have to specify it. can see the temperature is what? Empty, the pressure is empty, the molar flow is empty. Now the question is, why is it bringing just these three? Aspen has been designed in such a way that once you can specify these three, then and your composition of course, then you can fully specify a material stream. So you can liken it to what? The degree of freedom in specifying what? A material stream. So how do you do that? You double click on it, it displays the page, and then you can see that the name is what? The stream name is what? One. You can change that name. Let me give it my own name, Steven, and then okay. You press enter, it move on. Now the vapor phase, what phase are you dealing with? Is it liquid or gas? And I told you yesterday it can either be in form of liquid or gas or something between. So it has a range of what? 0 and 1. Now your temperature also, what temperature do you want? Let's just assume temperature of what? 100 degrees C. You can go for 100 Kelvin, you can go for, you have all the units there, the Celsius, the Kelvin, the Fahrenheit, the Rankine. So whichever one you need, click enter. Also the prayer. But take note, the status bar below here says what? Unknown composition. Unknown composition. You have composition here where you have worksheet condition properties, composition. So let's specify the composition. We are doing it only methane, isn't it? So methane means what? 100%. That's what we are doing. So you can just click on edit and then you input what? 1. And then take note of, I mentioned this yesterday, if you haven't forgotten, where you have the mole flow, mass fraction, liquid volume fraction, mole flow, mass flow, and all that. So you are dealing with that. You are dealing with that on this part. So you have a range of what? 1 and 0. So moving on, when you click on OK, you have your stream specified. And then you have what? The unknown prayer on this part. Are you with me? So you have the unknown prayer on this part. So when you are done with this, it means your prayer here is what? Empty. So let's assume a prayer of 5 bar. I'll do that. Let's go with 5 bar. Now once you click on it, you can see that your system is what? Active for what? Unknown flow rate. Now, without even putting the flow rate yet, you can see that your vapor phase has what? 1. What does that mean when you have 1? I told you that it ranges of what? 0 and 1. So what does this mean when you have 1? What does this mean when you have 0? So these are things you need to know. So now let's input the flow rate and see what happens to our whole system. Let's input 100 or so kilogram per hour, enter, and then you have OK as your system. Do we get that? Now look at it. You have some values in what? Black colors, and you have some in what? Blue colors. What it means is that the ones in blue colors are the ones you can manipulate. They are what? What do you call them? Do you call them dependent or independent? So they are what? They are what? So they are the ones you can manipulate, their values you can manipulate, but the ones on black colors you can't manipulate them. Do you get that? You can't manipulate, you can't touch them. The system calculated that based on what? Your input variables. So these are your input variables and these are what? Your output variables. Do you get that? So that is what you need to know. So you can see that you have just 3 of them. That's why you have 3 what? Degrees of freedom in specifying your material stream. So that is that. Now look at the color now. The color has changed to what? A deep blue from what? A light blue. So this stream is now what? Fully specified. I have to get that. So moving on to today's, now let's still make use of this one in today's work. Let's make use of it in today's work. And how do you do that? Go back to our PowerPoint where we have the whole stuff. Now you have this example that says what? We, okay, you don't have to use this one again, but under, of course we are modifying now. Now let's look at this question. This is a question relating to a pump. The question says pump are used to move liquid. Of course you know that they are used to do what? And also they do what? They increase the pressure of the liquid. Water has 180 degrees C and 3 bar is fed into a pump that has only 10 efficiency. The flow rate of the water is what? 100 kilogram per hour, and its outlet pressure from the pump is what? 84 bar. Using Penros's equation of state as a fifth package, determine the outlet temperature of the water. If the outlet temperature of the water is 200 degrees C, what is the efficiency of the pump? How to all get that? Now you have 2 questions from this part. two questions you are looking at. The first one is to look for the average temperature at where 10 degree efficiency at all these parameters. And the second question is what? If the average temperature is not 200, what is the efficiency? So that is what we are looking at. Now, let's go at our simulation environment. Let's create a new, just come to end to create a new worksheet, isn't it? You know, we are trying to deal with what? A pump now. We are dealing with a pump. Are you with me? We are dealing with a pump from this question. A pump. So look at it very well. Now, from this place, what components do you have? Of course, you see that you have water. Only water, actually, only water. That's what you have. Because when you are dealing with pump, mixed of water. But can someone tell me when you are dealing with gas, what do you make use of? That's the question for you to answer later on. So we are dealing with water here. Water at what? 120 degrees C and 3 bar at an efficiency of what? 10. So let's go to our Aspen Hysys again. So from our Aspen Hysys, you have the component list as what? Only water. So you type water under your search, or you look for either H2 or water, anyone, just type it there. You have your water. Click on it, highlight it, then do what? Add it to your system. Now you've added it. That's the only component you are dealing with. The next thing is to do what? Go to our food package. According to the question, it was said that your food package is what? Pen Robinson. So if that's the case, you do what? Add Pen Robinson to it. You add what? Pen Robinson. And then you are done with that. So once you've added it, what do you need to do? Go to your simulation environment to do the next thing. And then under your simulation environment, you know you are dealing with only water. Don't forget that. So you bring in what? Your material stream first. You bring in your material stream, and then you do what? You fully specify it. Now that is your feed, isn't it? And then from your system, you know that it has been specified that you have your water at what? 120 degrees C and 3 bar, and it has a flow rate of what? 100 kilogram mole per hour. So moving on, you have double click on it, of course, rename it as what? Water. Enter. Your temperature is what? What is your temperature? 120 degrees C, and your pressure is what? 5 bar. So you come back here, and then your temperature is what? Sorry about that. Your temperature is 120, 120, 120 degrees C, and your pressure is what? 5 bar. Are you with me? Now, if you are dealing with water, can someone tell me what the condition will be without me putting it? The condition will be what? 1, isn't it? Because you are dealing with only water. So you go to competition and then you do what? You add it to it, which is what? 1. Enter. And then you click on OK, and your then it says what? Go back to your condition. Now your flow rate was given as what? Were you given the molar flow or the mass flow? The molar flow, of course, because you have what? 100 kilogram mole per hour. So you come back here and then you add it to your system. Under your molar flow, you have what? 100 kilogram mole per hour, and then on hitting enter, your system says what? Okay. So when you close this one, you can see that your water stream, material stream, has been fully specified. I hope you all got that. So now let's go back to our question. Our question says water is fed into a what? A pump that has an efficiency of what? 10. A pump that has an efficiency of 10. So you come out your model palette and then you look for pump. You can just type pump here and then you have it. When you type pump, this is your pump. I hope you got that. Then you hold it down and then you drag it to your simulation environment. Do you get that? Now to now add your water stream to your pump, you double click on it, on your pump of course. And then you have this page that says the inlet, outlet, energy stream, and then full package. And then you have the design, the rating, you have the worksheet, you have the performance, you have the dynamics, and then you have that. So under your design, your inlet stream will be what? Your feed, which is your water. Are you with me? And of course, under your outlet stream, water will also come out. So you can just call this water 2. Take note, you can't have water and water. You can't have both the inlet and the outlet holding the same name. So you have to denote it with another name. That's why I added 2 to mine. On hitting enter, the message bar says what? Requires an energy stream. Of course, you need an energy in order to power your pump. So the way we denote energy streams basically here is by using the alphabet Q, and that is, I'm sure you know that it is mostly used for energy. So use Q and followed by the name of what the unit operation you are dealing with. So here I'll use Q pump because I'm dealing with pump, and then you hit enter. You get that? Now the energy you hit enter. After that, you have what? Unknown duty. Now what is duty? That's like the value of the energy. That is what it's active for. But according to our question, you can see that we were not given that. But we were given was the efficiency of the pump. Do you get that? Now normally, initially, the efficiency of the pump would be there, would be in the system. Now you won't have 100% efficiency. I don't think so. You won't have. Now clicking on parameters, look at it. The adiabatic efficiency says what? 75%. But according to our own design, we have to do what? Work with a 10 efficiency. So I like an input 10. I have to do that. Now we don't have the delta P, we don't have the pressure drop. But what do we have? From this question we have what? The outlet pressure from the pump is what? 84 bar. Take note of an error. The inlet pressure I used was what? 5. Don't forget that. So now you have what? The outlet pressure of what? 84 bar. So going back to our simulation, our Hysys, now you have what? You can either do it from this page, that is your pump page, or you can do it individually, that is you can go to your worksheet whereby you can see that from the worksheet you have the water, the inlet stream, water to the outlet stream, and then Q, the energy. Or you can do it closing that page and doing it what? Individually, that is by clicking on water 2. Do we get that? So you can do it either ways. So let's do it from the pump. Double click on the pump and then look at it under water 2. It was said that the pressure of what? The outlet stream is what? 84 bar. The outlet pressure from the pump is what? 84 bar. 84 bar. Take note of that. 84 bar. So input your 84 bar and what do you have? And then you see what happens to your system. The system says what? Okay, so it has been what? Fully designed. You fully designed this pump. So the next thing is just for you to study your system, that now if I have this particular inlet stream, what happens to my outlet stream? Don't forget that I told you regarding the color of your values. The ones in blue means the ones you can what? You can vary, you can manipulate them, but the ones in black you cannot manipulate them. Don't forget that you cannot manipulate them. So now look at the outlet temperature. 100 and what? 37.7 what? Degrees C. Don't forget the initial one was what? 100 degrees C. That was what? The full stream. But now the temperature has been increased. At the same time the pressure was increased. But the molar flow was constant. So that is how you do your system. That's how you study your system. So that is all about pump. But we are not done with the question. Look at the question. It was said that now we are now determining the outlet temperature is now what? The one I said earlier, which is what? 137.7 degrees C. Now that's your outlet. Now let's now go back to our question. Now see, what if the outlet temperature is now 200 degrees C? What is the efficiency of the pump? Do you get that? So if your outlet temperature is now 200 degrees C, what is the efficiency? Outlet temperature is now 200. What is the efficiency of the pump? That's the question now. So you can either come back now. Let's go back to Hysys. That is doing it now. You know this is your temperature 137, and that's a what, a black color. You can't manipulate a black color, as I said. You can't manipulate it. So what do you have to do? Close it, because you know that's value you have to change to 200 degrees C in order to make. So you now come back to your pump. Are you with me? Now when you go back to your pump, go back to your design, go back to your parameters, then remove the efficiency, just delete it, and then hit enter. What do you have? Unknown duty again. Are you with me? So if you should go back to your worksheet, you can see what happens to your water, your outlet water. You can see that the values has been what, deleted, because you know you are looking for what, the efficiency of your outlet. That's what you are looking for. So now in order to do that, you can do it from here, you can do it individually. So let's do it from our pump, from the worksheet. Now the new temperature says what, outlet temperature is what, 200 degrees C. What is the efficiency? So your outlet temperature is now what, 200 degrees C. Hit enter, and what happens to your system? Okay. Do we get that? So now let's now go back to our design parameters. What is our efficiency? That is what, 2.27. Can see that the efficiency is what, lesser than 10. So that is how you work with your pump. So the efficiency of the pump at 200 degrees C outlet temperature is what efficiency? 2.27 percentage. Do we get that? So that is how to work with your pump, and that is all about the pump design. So you are done with your pump, and that's about that. But let's move on. Now we under our we are done with the pump. Now let's look at it. Assuming we are done with the pump, what else can we do with it? Let's see. Let me look from that. No, I don't want us to combine this one. Let's go back to our module under the content. You know, we talked about what, pump, compressor, expander. Let's combine our compressor suite with the pump. I'm pretty sure you know what a compressor does, isn't it? A compressor does what? What? Hello? I hope you are still with me. A compressor does what? If you ask that, what does a compressor do? What will you say? It is used to do what? Just like the pump, increase the pressure. They both increase the pressure, but compressor does that for what? Gas. Why pump does this for what? Liquid. That's the only difference between the compressor and the pump. One increases the pressure for the for liquid, while one increases for what? Gas inlet. So that's basically the difference between the two. So now let's go back to our ICs and let's just combine. Now just look for where you type your pump. Let's just look for compressor. Compressor. Now you have your compressor. Can you see it? So drag it to your environment, isn't it? Now we'll be assuming the data for the compressor, because we are trying to merge it with what? The pump. So the outlet from the pump will be the inlet for the compressor. So how do you do that? So double click on your compressor. The inlet will now be what? Will be water 2. Do you get that? And then the energy stream, of course, requires a product stream. So let's call the outlet from the compressor what? Pump out. Let me give you that name. And it says what? Requires an energy stream. How do you give energy stream? Don't forget, how do you denote it? Q hyphen and then the name of the unit operation, which is what? Compressor. Hit enter. Do you get that? Now it says what? Liquid in the inlet stream. Don't forget, for compressor, what do you deal with? You deal with gases, not liquid. But you are dealing with water here, so that is why this system is telling you that liquid in the inlet stream. So can you see that now when you are doing something of course, the system can guide you along the as long as you follow instructions. Normally a liquid should not flow into a compression, a gas should flow into it. So that is why it is telling us that what a liquid is already inside this system, that is something is wrong. So now let's just move on and see what happens. So you should now go back to your under your design, go to your parameters, now see what you have here. You have your adiabatic efficiency as of 75 again. Now if you remember for your pump also, you have the adiabatic efficiency initially at what 75, that is your system can only operate at what 75 efficiency. That's like the maximum it can operate in. Do you get that? So let's go to our ratings, go to your worksheet and then look at it. Now if you can see that the temperature and the pressure for the outlet stream is what empty. Are you with me? And you know that initially the pressure should increase. Are you with me? The pressure should increase, isn't it? So let's assume I want to increase this one from 84 bar, the pressure from 84 bar to let's say 100. What happens? Will my system work or will it give me an error? Now look at it. Even though the rest of the values were calculated, do you notice that? But the system still says what? Liquid in the inlet stream. So you can't have a liquid in it. Although this is what we call this a flash calculation in Hysys. It has already calculated that even if you have water in it, these are what you probably would have, because water denotes what liquid. Everything in your system is liquid. But when you have one, it means everything are gases. Now look at it. The temperature has been increased also. Look at it. Study your system and see what you need to see. So look at what you have. Now when you close this string, what happens to this? You can see that you have the color, it means it's converged, but look at it. The unit of vision still has what? A yellow line surrounding it, like did I say border, a border line surrounding your unit of vision with a yellow line. A yellow line. What does that mean? It means although you have a converged system, but your unit of vision is not okay. Do we get that? But whereas look at this for the pump, you can't find this yellow line attached to it. You can only find black. It means it is okay. But for this one, it is not okay, because you have what? Liquid in the inlet stream. That is it. Because you have liquid in the inlet stream. So do we get that? But if you should have a gas coming in, then your system will be okay. And that is that about a pump and a compressor. So if you have any question, you have my phone number, you have my email, you can get in touch with me anytime. And once again, you can get in touch with me. Once again, this is my, let me go back to it. And that's my details. You have my email there, you have my phone number. You can just send me a mail, you can give me a call, a text message. I will get in touch with you as soon as I can. So moving on, let's see what else can we do with this. And then for today, that will be the end of our class. Just try and practice with expander and get in touch with me. Practice with expander, see what you can do with expander. You can either attach it to this system or you can create it individually. So work on it and let's see where we can get to. So I hope you enjoyed the class. Thank you very much. Once again, I'm Ariel Steven by name. Thank you and God bless you. See you next class, same time, same period. Thank you very much.